DDI CADcast is part of our What's New series, covering SOLIDWORKS flow simulation. Now, SOLIDWORKS flow simulation has released several new and diverse functionalities for 2013. Shown on the screen is a summary of the different topics we're going to be covering today. Let's start with a brand new functionality called Compare Configuration Mode. Now, in past releases of SOLIDWORKS flow simulation, it has been a bit of a pain to have to go in and aggregate and allocate all of your data. Since every project had a set of results, you basically had to go to every single configuration, grab the results, put them in a certain common area, go to another configuration, grab those results, and then compare them in another location, such as Excel or a PowerPoint presentation. In 2013, we can now use the Compare Configuration Mode tool to compare the setup and results of fluid flow analyses. Everything is now done locally within SOLIDWORKS without having to go to Excel, PowerPoint, or another peripheral product to compare and contrast your SOLIDWORKS flow studies. Now, the way this tool works is, ideally you would like to have several configurations with studies that have been done with different boundary conditions or just some sort of common variable that gets changed, and you would like to have all of your studies run at this point. On my screen you'll notice we have two configurations, a model that has a cylinder with a block, another model that has a cylinder with a block with a hole located inside of it. Now, to use the Compare Configuration Mode tool, we can access this from the Flow Simulation Flyout, Results, and Compare. The Compare Configuration Mode interface pops up from the bottom, and now we're able to go in and select all of our different parameters that we can compare with. Simply go ahead and checkbox the parameters of interest. Over to the right, we also have the different projects that we would like to compare against. We have the ability to compare different configuration results from point parameters, surface parameters, volume parameters, goal plots, and any plots shown in the graphics area at the time of using the Compare tool. Once all items of interest have been selected and checkboxed in, we're going to select the Compare button. Once the Compare utility has compared all of my items, we can step through the different tabs to take a look at the results. Choose Active Scene so we can get an active current screenshot of what's currently in our graphics area. Double-click on each screenshot to open it in Windows Picture Viewer. Now we can toggle between all of the different active screenshots that we were able to compare with. Select Point Parameter that we may compare amongst the different point parameters per configuration. In this particular example, we're taking a point at the corner of our cube and comparing the velocity in meters per second. Select Surface Parameters, and now we can compare this surface parameters per configuration, just like we could with point parameters. Also, we can compare the difference between the different configurations by hitting the delta icon. We can also export any of these different sets of results by hitting the Export to Excel icon. Lastly, compare the different goals created for each configuration. You could look at the final outcome for each individual goal, in this case, static pressure. You could also compare the convergence plots that were created while solving for each individual project. We can further interrogate different aspects of our goal as far as travel, CPU time, and also we can display the different values, as well as export the data to Excel. And this is Compare Configuration Mode in Flow Simulation 2013. The next ability to point out for Flow Simulation 2013 is the ability to add erosion plots in the form of surface plots as well as surface parameters in your results. When you're exploring your flow structures with two phases, whether that be water and gravel, or any liquid and solid, you can display these erosion rate surface plots or determine quantitatively with surface parameters what these values are with any surface involved in the flow project. Again, to be able to generate these erosion surface plots, you first need to create a particle study. Within the particle study options, be sure to specify under the physical features the erosion checkbox and run your particle study. After this post-processing step, you can now interrogate your results with surface plots. For more specific erosion rates, you may also interrogate using surface parameters. And this is the erosion plot in Flow Simulation 2013. The next ability has been highly sought after by many industries throughout past major releases of SOLIDWORKS Flow Simulation, and this is the ability to add evenly spaced streamlines to any surface within the fluid domain. This gives you the ability to project and visualize these fluid field lines on any selected surface. To activate this ability, simply create a new surface plot, and inside of the Surface Plot Property Manager, you'll find a new category called Streamlines. Now, under the Evenly Spaced Lines category, we can specify any vector parameter in the flyout and adjust the spacing and thickness options. Once we select OK, we can interrogate our models with these evenly spaced streamlines in an interactive real-time mode. This gives us the maximum amount of detail in even the most complex surface models. Now, in order to ensure that this ability works for your machine, please make sure that you're on a supported video card and video card driver for your machine's configuration. In addition to the evenly spaced streamlines or lines, we can also specify to display these vector lines using the line integral convolution technique. And this is the Streamline ability in 2013. This text enhancement greatly increases your flow project's file management. We've changed the way that we organize our flow projects in SOLIDWORKS Flow Simulation. At the top of the SOLIDWORKS Flow Simulation project design tree, you'll notice that we have a new section which itemizes every single configuration. Below that configuration, we can organize all of our different flow projects. Now, this opens up a whole other layer to flow file management or project management. We can now have multiple projects within one configuration. Now, a nice functionality to highlight here is if I activate a desired project, it will automatically activate the corresponding configuration. Next, let's start talking about how Flow Simulation handles geometry in 2013. In this new release, we've added several different enhancements that will help increase the productivity of setting up a flow project. The first productivity enhancement is called leak tracking. Now, in this particular model, we've actually made a small, minuscule hole and added a lid. Once I remove that particular lid, the software is going to notice that we have a change in our geometry and will ask us to reset our computational domain. I'm going to keep my same domain, and I'm also going to keep my same mesh settings. Flow Simulation now prompts you in its internal task to check for internal fluid domain and gives us this new pop-up. If I proceed and I say no, the software will give me a little status area to the lower right of my graphics area that will indicate the status of my internal analysis. Now let me reset my example here, and let's proceed and let's say yes, and let's go to Create Lid Location. Now if I say yes and proceed to the Create Lids Property Manager, the leak tracking functionality will allow me to go in and select an internal face and select an external face to this model so that we can map out a potential route in which my fluid medium is escaping my housing. Let's select the inner cylindrical face of the cylinder as my start face, and the external surface of the cylinder as the end face. After hitting Find Connection, the software will go ahead and verify and propose a specific path that my fluid medium might exit the computational domain. After we verify the leak path, we can now create a lid and seal up our model for an internal analysis. After flow simulation has done the internal fluid volume check, you'll notice that the no fluid indicator has been removed from the graphics area in the lower right hand corner. The next productivity enhancement is called List All Component Faces. Now let's say I have a boundary condition and I wanted to apply the condition to most surfaces of a solid body. Instead of picking those individual surfaces one by one, I can choose the entire surface body and then choose the icon for List All Component Faces. This can apply the defined surface boundary condition to all faces of the selected solid body or component. At that point, if I wanted to remove one or two of these surfaces, I could certainly do so. Another enhancement, not really visible from the application standpoint in flow simulation, deals with our mesh settings. When defining a mesh control, we had a limitation of 1,000 basic cells in each direction with any of our mesh controls. In Flow Simulation 2013, we can define a finer mesh for more complex or larger models, effectively increasing our accuracy and sensitivity in our results. Lastly, I want to talk about check geometry inside of flow simulation. Typically, for an internal analysis, users will use check geometry under flow simulation tools to check for problems in your geometry and component interface. In Flow 2013, the check geometry option has now been redesigned to reside inside the property manager just to keep it visible. All functionality is still retained in this form factor. And this is geometry handling with Flow Simulation 2013. The next topic is actually an enhancement to our temperature condensation ability in flow simulation. The ability to model condensation in flow has been extended to allow and analyze temperatures below -70 degrees Celsius. This allows you to expand on your condensation ability and simulate steam or humidity in very extreme conditions. Moving along, let's talk about the new parametric study interface in flow simulation. So for those of you that aren't familiar with parametric study in flow, parametric study allows a user to take an existing project and be able to change certain parameters such as boundary conditions, and allows you to interrogate and explore results, or you can also have a goal optimization ability that lets you work backwards within flow simulation. For example, if I have a situation where I have an enclosed piston and I want to figure out at what length of a piston do I get a certain pressure as a goal, I can optimize geometry such that I get the actual desired pressure with my geometry. In 2013, we've redesigned the UI. In previous major releases, we had a small wizard tool that we had to click next and back, and that was our ability to navigate through the interface. Now we have a tabbed interface similar to design studies in simulation, our sister product. To activate the parametric study mode, select the flow simulation flyout, choose the solve category, and select parametric study. Another approach is, if you know the input boundary that you would like to modify, you can simply right-click over that boundary and select parametric study. This new interface allows for easy selection of input variables and output parameters to set up your study. We've also broken down our interface into two types, the what-if type and the goal optimization. The what-if mode allows you to go in and vary a set of selected parameters, such as dimensions, any input boundary conditions, and it allows you to explore your results. Goal optimization allows you to vary only one of the selected variable parameters in order to obtain a specific goal in mind, essentially allowing you to either vary a specific dimension or other input to get the desired goal. To perform the setup, we simply select the type of parametric study we'd like to obtain, choose the parameter or parameters that we would like to vary within our exploration, in this case, mass flow rate, and now we can enter our values for what we want our mass flow rate to be either discretely or within a range, all from the interface right above. Once we entered our input variables, we can specify our output parameters. These can be any of the goals that you specified during the initial setup of your project. Lastly, choose the Scenario tab, and this will give you a summary of the different iterations the parametric study will go over. Now at this point, if you want to add additional goals or input variables, we can do so, and then update parametric study. We can also add a new computer and basically commandeer another machine, such as traditionally been available in flow simulation. Lastly, if you've done all the setup and you would like to save your setup, such as previous major versions, we can simply hit save, and the software will allow us to save this parametric study data in the traditional FWPS format we've had in the past. In this way we can save and perhaps run our parametric study at a different time. Once we're committed to run the study, simply hit the Run button, and the software will iterate and step through in series every single iteration. In the back end, you can see which iteration has finished, is calculated, or has not been calculated. Once we're done running our parametric study, we can interrogate our results like we always have within each configuration. And that's the new parametric study interface in Flow Simulation 2013. The last improvement mentioned in our What's New series for Flow Simulation is our improved eDrawings data plots. Any result plot saved in Flow Simulation saved as an eDrawings file now shows the corresponding legend in the graphics area, making it easier to collaborate and communicate amongst your peers with eDrawings. And this is what's new with regards to eDrawings and Flow Simulation in 2013. And thank you for viewing this Digital Dimensions CADcast. Please visit us at www.ddicad.com.